All right, so we're going to go ahead and find the derivative of x cubed minus 1. This one poses an interesting issue, one that I think you can handle, but we start getting into higher powers of x and finding derivatives, and this approach becomes cumbersome. So what I have to figure out is what is x plus h cubed minus 1. Now at this point we know what x plus h squared is, so theoretically we could take that expression and multiply it by x plus h, and you're going to get x plus h cubed. Just takes a little bit longer. If you remember a couple weeks ago, Mr. Middleman talked about the Pascal's triangle as a way to help you figure out how to expand a polynomial, a binomial like that. So I've written that down here. Remember, he talked about this was x to the 0 power. This was x to the first, x squared. This will be an x cubed polynomial. And really what this expression is telling us is that we're going to have coefficients of 1, 3, 3, and 1. We're going to have 1x squared, and because we're adding, it's all going to be 1x cubed plus 3x squared plus 3x plus 1. And what we've done is we've expanded x plus h cubed without having to actually do all of that, the steps in between to get there. So if you know your Pascal's triangle, it can be really helpful. So here is, and actually I missed the h's in there. So it'll be, I'll explain this here in a second. X h squared plus h cubed minus 1. So in Pascal's triangle, we have, if this is just x plus 1 cubed, okay? So if it's x plus h cubed, then what happens is, we start with, let me write this up here. We start with the powers of x that are decreasing. So you have your powers of x that go from 3 to 1 to nothing. And our powers of h kind of work opposite. So they're going to increase from right to, or decrease from right to left, increase from left to right. So it'll look like this, and then no h. And that's where that expression came from that you see up above. Okay. Now, if you need to just go ahead and multiply it all out, by all means do that. There's no harm in that at all. I just wanted to show you this as a shortcut. If you are able to use it and understand it, it helps when your powers start getting larger. So we're going to put in, remember our f of x plus h is right here, and our f of x is right here. So our limit is the limit as h approaches 0. This is going to be our derivative as h approaches 0 of, and we have that long expression that we just figured out for f of x plus h. And I'm going to be really careful, try to not miss any of the pieces here. And then we subtract f of x, which is just x cubed minus 1. And again, I'm not going to go through and distribute the negative sign or subtract, show that I'm not going to get rid of the parentheses, okay? I'm just going to know that x cubed minus x cubed, well, that's 0. And I'm going to know that negative 1 minus negative 1 is also 0. And that allows me to kind of work a little bit faster. So now I have the limit as h approaches 0 of, and everything I write at this point should have h's in it. And if it doesn't, then I know I did something wrong. And I mean, I'm in luck. I've done something right. So now I can go ahead and factor out an h. So I can get rid of that h in the denominator, because now I've got my giant 1. And at that point, remember, once you've eliminated that h in the denominator, that's when you can go ahead and plug 0 in for any of the remaining h's. So I'm going to have 3x squared plus 3x times 0 plus 0 squared, which those are both just 0. So I'm left with just 3x squared. So my original expression, f of x, was x cubed minus 1. My derivative was just 3x squared. And you might be starting to see some patterns happening here, and that's what we're going to explore in the next lesson.